Hello and welcome in this session of the course Pedagogy of Science. As a science teacher, when you deal with different topics in your classroom, you use different methods, different resources, different activities to give the opportunity to your learners to explore more. You help them by your explanations, you engage them by different activities, you give them opportunity to expand their knowledge, and you also evaluate by using different types of methodologies. When a science teacher deals with different topics in the classroom, all the topics cannot be explained by using the same method or the same strategy. The topic of the physics may require a different kind of methodology. The topic of biology may require different kind of methodology. The topic of chemistry may require different kind of methodology. Even within the physics, you may find topics which you can explain in the laboratory. You may find the topic in which you can utilize the daily life experiences of the learners and help them to build their concepts. So as a science teacher, what we need to do while we are dealing with different topics? And in today's discussion, I am going to discuss about how can you deal with the topic like electric current or electric circuit, which are the part of secondary science curriculum in different states and also in the NCERT. Most of the examples I have taken from NCERT textbook here because I have taken that as a standard content source. Actually, when we talk about the topics like electric current or electric circuit, our learners with whom we are dealing in our class, they already know about various things. They know what are the uses of electric devices at home and at workplace. They are also aware like bulb generates light, whereas heater generates heat. Fan rotates the air in the room and make it cool. Means the same electrical energy which is being used in different devices is giving different kind of outputs. The same electrical energy is being converted into light, is being converted into heat, and it is being converted into a mechanical energy which rotates the fan. But the question is, why so? Why is it happening? Students know about electricity, they have studied it in their elementary classes, so they are not in vacuum. You need to ask your students that what they know about the concept of electric current. Or do they know about the movement of electric charge? Few of may be knowing, few of them may not be knowing. But they must be aware about the flow of the water current or flow of the air in the one direction. So you can use such activities and such tasks to engage them with this content. How you can engage them? If you read the history of the electricity, there are three names which are very prominent. I am not talking about the discovery of the bulb and other recent developments. Gilbert, what he discovered in 16th century, in 17th century, then Volta, then Franklin. So what do you need to do? You can collect the stories of the Gilbert, Volta and Franklin, and you can share those stories with the students, not in form of a content providing methodology, but only to start with or to engage them in the classroom. Most of you as a science teacher have read about the very famous kite experiment of Franklin, that how Franklin flown a kite on which the top of that kite he attached a metal wire, and he used a switch in the wire with which the kite was connected, and then he felt the electric current when it was a rainy day and the kite was flowing near to the clouds. So that is a very famous story. There are many videos on that. So you can explain that story, you can show the video of that story to begin with, so that they know that yes, Franklin has discovered a very phenomenal thing, and how it basically transformed the whole concept of electricity in the country or in the world. So when we talk about electric current, we basically define it as the amount of the electric charges flowing through a particular area in a unit time. Or we can say electric current is the rate of the flow of the electric charges. But do you know, when the phenomena of electricity was discovered, no one was knowing about electron at that time. So if you see the initial text or the initial stories about the electric current, then earlier it was assumed that it is due to the flow of the positive charges, and the direction of the flow of the positive charges was taken to be the direction of the electric current. Then later, when electron was discovered, and it was established that due to the flow of the electron, the electricity get generated or the electric current generate, and it is in opposite to the direction of the flow of the electron. So later it was established, now we all know that the direction of the electric current is opposite to the direction of the flow of the electron, which are negatively charged. But conventionally, if you see, still students get confused here. Why? Because here we are saying that electric current is opposite to the direction of the flow of the electrons, which are negatively charged. It means there are two types of charges always, positive charge and negative charge. So if negative charge is flowing in one direction, definitely the positive charge is flowing in the another direction. So still many teachers and many students get confused that if it is opposite to the flow of the electron, it means it is in the direction of the positive charge. So conventionally it can be correct, but scientifically it is not, because positive charge is not responsible for the flow of the current. It has been established now that electrons are responsible for the flow of the current. So if the net charge Q, for example, flows across any cross section of any conductor in time t, then the current is defined as I equal to Q over T. Means the charge flown to a conductor per second. The electric charge, basically we use the unit to measure the electric charge called coulomb, and which is basically equivalent to the flow of nearly 6.6 into 10 to the power 18 electrons. So if 6 into 10 to the power 18 electrons are flowing per second, it is 1 coulomb. So the electric current is measured in ampere. So if 1 coulomb charge is flowing per second, means 6 into 10 to the power 18 electrons are moving per second through a conductor, then the electric current in that conductor is 1 ampere. Nowadays, even the smaller units of the ampere are being used, so you can ask your students to find out the devices at their home where the charge is written in milliampere. So 1 milliampere is 10 to the power minus 3 ampere, and 1 microampere is 10 to the power minus 6 ampere. How do we measure this electric current? We measure it with an instrument called ammeter, and ammeter is always attached in series. We will talk about the series and other combinations in some other lecture. So how you can engage your learners here? There are two ways. Ask your students to explore about Andre Marie Ampere, what he has discovered, what was the discovery. You can ask your students to read the ampere written on different electrical instruments at their home. They may read it on mobile charge, they may read it on fan, they may read it on electric iron or any electrical devices which they basically use at their home, and even sometimes it is written on the switch also where they plug their instruments, that how much ampere this will deliver or this can current. And then the concept of ampere, you can explain them more easily if you are not using such instruments, if you are not using such devices, if you are not correlating it with their daily life experiences. It may be a difficult concept, but it is not a difficult concept. It is up to us as a teacher that how we deal with different types of concepts when we are dealing with it. Then comes the concept of electric potential and potential difference. Again, the question is, students may not be knowing what is the potential or what is the potential difference or how it affects the flow of the current. But they must have seen that how water flows from the tank to the tap. Why tank is always at the height and tap is below. So why the water flows? If you ask them, you can show them picture, you can ask them questions. They will tell you that the pressure exerted by the water in the tank or the pressure exerted by the air on the tank water pushes the water towards the tap and it comes down. Then you can give them an activity also that in one bottle you can keep the water and you can connect it with a small pipe. And let students try to understand that how water flows from the pipe and when it flows. When they put it at a height, when the pressure is more, only then it flows. So can they identify analogy? Can they identify any analogy between these concepts? How you can use the concept of flow of the water or the pressure on the water with the flow of the current? Why you need to do this activity? Otherwise they will face difficulty in understanding the concept of potential or potential difference. So here you can tell them that electrons move due to a difference in the electric pressure, which is known as potential difference. So like water exert pressure, air exert pressure, there is also an electric pressure. And the flow of the electric charges from one point to another is basically due to the difference in the potential at the end of the wire or at the end of the conductor or at the end of the circuits, and that difference is called potential difference. So here you can define by creating this analogy in your class that potential differences between 2 points in an electric circuit is defined as the work done to move unit charges from one point to another. For example, if 1 coulomb charge is moving from one place to another place, from one end to another end, from one point to another point, how much work is being done for this charge transfer, for this charge movement? That work is basically measured in terms of potential difference. Because the charges in the conductors also possess energy due to the position, and that energy is called electric potential. So the potential varies for each charge in an electric field. If there is a difference in the potential across the conductor, how you can do it? There is a very good experiment I will explain soon when I will talk about the Ohm's law. That by increasing the number of the cells or number of the batteries at one end, this potential difference can be created. So when we connect the cell in any electric circuit, a difference in the potential is developed at the two ends, which basically helps to move the charge, or we can say which helps in current flow. How you can connect this concept again with their daily life experiences and the activities? Let you ask them what is a voltage, what they know about voltage. At home they often listen that today voltage is high, the voltage is low, this instrument is not working properly, it is not functioning properly, the AC is not working properly because voltage is low. So what do you mean by this voltage? Do they have any idea about it? They may be having, they may not be having the scientific concept of voltage, but they know that voltage is a concept which determines the flow of the current. Now here you can ask that if the functioning of an instrument is related to the voltage, does it mean that it has any relation with the electric potential? Because when we talk about electric potential, we all know that electric potential is denoted as V, and V is basically the short form of volt, which is named after Alexandro Volta. Now here you can ask your students to collect the information that what Volta has done. What was the experiment of Volta? Because the electric potential difference is expressed in the unit of volts, that's why it is sometimes referred as voltage. So from here the term voltage has emerged, because volt is the unit of the potential difference, and that potential difference is responsible for the flow of the current. So the thing, the character or the property of the electricity which is basically measured in terms of volt, sometimes referred as voltage in general terms. So here you can introduce the concept of volt and voltage, and you can also tell them that how you measure the voltage. You measure the voltage or the potential difference by using an instrument called voltmeter. So the ammeter and voltmeter can be given to them, let them connect it into the circuit, and let them try to explore the what voltage is there, or what potential difference is there, or what current is flowing. So this potential difference between the 2 points is basically the work done per charge flow. So you can say V equal to W over Q. The electric potential difference between the 2 points in an electric current carrying same current is the work done to move a unit charge from one point to other point. Remember, when you are helping them to connect the ammeter and voltmeter in the class, or you are asking them to draw the diagram or diagrammatic representation of an electric circuit, ammeter is always connected in a series with the instrument through which the current is flowing. Why? Because you want to know how much current is flowing. But voltmeter is always connected parallel to the circuit because we want to know the potential difference between the two ends. So we need to connect both the ends with the voltmeter. So this is a rule, thumb rule, that when we want to know about the current, we connect ammeter in series, and when we want to know the potential difference, we connect voltmeter in the parallel to the circuit. So when I am talking about circuit, I think now that is the time that we should move from these concepts to the circuit. But before talking about the circuit or the circuit diagram, you need to explain various symbols which are being used to draw any circuit, so that they draw circuit effectively. For example, what do you mean by an electric cell? When we reflect any electric cell in the circuit, what is the symbol? There are two parallel lines, one is small, one large. The large one is positive and the small one is negative. If it is a battery or combination of cells, then you connect more cells in the same way. Then what is the plug key? Switch. If switch is open, it is only two brackets connected with the wire. If the switch is closed, there is a dot in between. What is a wire joint? How we reflect the crossing of the wires without joining. If one wire is crossing the other wire and not touching it, then how we can show it? There is a symbol. How we reflect the electric bulb? How we reflect the resistor of the resistance? How we reflect the variable resistors or rosters? How we reflect the ammeter? How we reflect the voltmeter? All these symbols need to be explained to the learners, and you can use a picture puzzle, you can use a simple quiz, pictorial quiz, or you can give them an exercise, a small exercise, 1 minute, 2 minute exercise, where they may be asked to draw different symbols. Because if they know these symbols correctly, there are less chances to have any error when they make any circuit diagram. So what is the circuit? Circuit is not something which is a very technical concept. The students have already observed how electricity flows. They know that why switch is connected with the bulb, fan, etc. at the home, because every electric instrument which they use, they always connect it or plug it into the board, switchboard, or the switchboard is already connected with the wires which are connected with the electrical instrument, like AC, like fan, like tube light, like bulb. So they know that there are switches, there are instruments, there are wires, and when these are connected in a sequence for the smooth flow of the electricity, that connection is called electric circuit. So it is a path basically through which electrons flow from a current source, and the point where these electrons entered in the electric circuit is called the source of the electron, and the point from where the electrons leave the electric circuit is called the return or the earth ground. So there are always 2 points in any circuit. Here it is a simple diagram you can see of a circuit where we have connected one key, two cells, one bulb and one emitter. So emitter is represented by A, bulb is represented by a coiled symbol, cells are represented by parallel small and long lines with positive and negatives, and K is there, the key. So here even in this picture you can see that there is an arrow showing I. I is the flow of current. So current always flows from positive to negative, but electrons flow from negative to positive. That's why conventionally still many people believe, and here your intervention is required, because if this misconception will remain in the mind of the students that the direction of the current is the direction of the positive charge, then it will hamper their understanding when they move towards the more technical concepts of the electric circuit. So though conventionally it looks like, but they should be very clear that no, the flow of the current is basically due to the flow of the electron, and flow of the current is opposite to the direction of the flow of the electrons. Then when we talk about the electric circuit, we also tell them that the electrons, the charge carrier in the electric circuit, flow in the opposite to the direction of the conventional current flow in the electric circuit. Here is a picture where the green line is showing the flow of the electron, but the red line is showing the flow of the positive charge. So conventional current basically flows through a circuit from a positive side to the negative side, but the electrons flow in the opposite side. I am again clarifying this here with the help of this picture. Then comes the concept of the Ohm's law. Especially at the secondary level in class 10th, this concept has been introduced in the NCERT textbook, maybe in your state textbook also this concept has been introduced at the same secondary level. But when we start teaching about the Ohm's law, basically we start with the law. Traditionally, what law is, how we can define it. I think there is the problem which sometimes makes easy concepts very difficult for the students to understand. So what do you need to do? I am suggesting you an activity that you make some small groups of your learners, provide them cells, emitters, voltmeters, resistors, connecting wires to each group. And you ask them just to connect everything in a sequence, because they already know how electric circuit has been established. And you ask them to connect the cells in different numbers in different times, and just note down the reading of the emitter and voltmeter. Let them do this on their own. You don't tell them you are going to teach about the Ohm's law. And then you ask them to make a table. How many cells they have connected in the circuit? What was the reading of the current? What was the reading of the potential difference? And what is the value of B over I? You also ask them to draw a graph on x-axis and y-axis. On y-axis they can take voltmeter, on x-axis they can take emitter reading. Let them draw a graph. They will themselves surprisingly notice that the line is a straight line in the graph, and the answer or the ratio B over I is a same value, which is a constant. So while analyzing the graph and analyzing the table, they will realize that graph is a straight line and the ratio B over I is a constant. So here you can explain, you can intervene that voltage across the ends of the conductor is directly proportional to the current flowing through it, keeping the temperature constant. This relationship is called Ohm's law. Basically, the explanation of this relationship between the voltage and current was given by Ohm. That's why it is called Ohm's law. So with this, I think you can easily explain what Ohm's law is. B over I is a constant. On removing the constant, you will get a R, and what R is called resistance of the conductor. The resistance of the conductor is basically the obstruction posed by the conductor to the flow of electric current. So here you can explain that resistance is defined as the ratio of the potential difference across the ends of the conductor to the current flowing through it, that is R equal to V over I. The SI unit of the resistance is Ohm, which is a Greek letter. Resistance is inversely proportional to the current, that is, the resistance is increased if the current flowing through the conductor is reduced or vice versa. And the resistance of a conductor depends upon the three factors: length of the material, area of the cross section, and nature of the material. And you again give them activity. You give them different material, or the wire made up of different material, wire of copper and wire of aluminum and other wires. You give them some wires with more width, some with less width, 1 mm wire, 0.5 mm wire, 2 mm wire. Let them experiment. When they will experiment, when they will observe, they will definitely establish these relationships which generally we present theoretically in our class, which we should not. So science is always enjoyable, whether it is physics, whether it is chemistry, whether it is biology. It is up to us as a teacher that what methodology we are using to explain the concepts in our class. If you engage your students, if you use their own knowledge, their understanding, the knowledge which they are gathering from the surroundings, and you try to correlate it with the concepts which you are going to explain, I think you will be able to explain the most complex concepts of science in very easy way. The only problem we as a science teacher basically facing, that many times we disconnect the concepts of science with the society or with the life experiences, and from there the problem emerges and students start to feel that science is a very difficult subject. Science is always a subject of experience. Science you cannot teach through explanations, through theoretical writings, only by rote memorization of the facts or the principles. Even if there is a fact, even if there is a principle, there is an application. So what as a teacher you need to do? First you try to find out what application is there. Start with the application. Develop curiosity among your students that if it is happening, why is it happening? What are the concepts? How this concept has emerged? Share the stories, the very inspirational stories are there of the scientists who have discovered various phenomena in science. So I think with this, you will use different methodology in your class. You will explain not only this concept but other concepts also which are related to the physics and the science, and make your teaching learning enjoyable and make your classroom an enjoyable classroom. Thank you very much.